So the talk is about extending the layout inflator. The whole purpose or the idea behind giving this talk is that I've been kind of frustrated in the past, and whatever time I wanted to apply fonts to my text views or any derived text views, it's a big pain in the butt because most solutions that I've seen is people subclassing all the text views that they wanted. Then you have the problem of app compat because then you have the app compat classes. So you should preferably be deriving from those because you don't want to lose features added by the support libraries. And you end up with a lot of classes that basically do the same thing. So you can factor out those implementation in some utility class. But in the end, those classes do not add much value to the base classes. So I was exploring another solution to implement this. I do want to give a disclaimer. Apparently, there's a library called Calligraphy, right? That I did not know about. I'm guessing they do something similar that I'm going to present here. But I did not look at their source code or decompile anything that they were doing. Thank you. So the LayoutInflater is this class that magically inflates layouts. You basically just give a layout ID, and you get back a view, and you do with the view whatever you want to do. It's been there since API level 1. So it's a pretty old thing in the framework. And let's see how can we actually extend the LayoutInflater. Even though it's an abstract class, so you can subclass it. But if you look at the source code, by subclassing, you can't really add much value to it. Or you can add it in a way by going against the framework. So subclassing is not a good idea. Also, you end up in a problem how you're going to use that LayoutInflater. Are you going to inject it? How you are going to provide it? If there's a third-party library that uses it and inflates layouts from resource, what's going to happen to those? So extending the LayoutInflater on its own is not necessarily a good idea. Also, it's an abstract class, and there's one concrete implementation in the Android SDK, which is called the phone LayoutInflater, which adds some value to the basic class. But you cannot be sure if the implementation on the device is going to be the same. Potentially, a device manufacturer might add new implementation or extend it in their own way, so it's not necessarily the best idea. There's no concrete implementation in the framework, I mean the public SDK. So this is just going through the basic ways how you can get a LayoutInflater. This is very important because any way you extend it, you want to make sure that whatever you add to it is always going to be there. So one way of getting it is obviously getting it through context or using the from static method, passing in the context. Internally, it does the same things. It also has a clone in context, which just basically creates a new instance of the LayoutInflater, which is going to be different from what the framework will provide you. You can't really instantiate it. All the constructors, two constructors, are protected. So I think last time there was a talk about system services and services in Android. So this kind of ties into the same framework. So it is provided as a service. And you can see it, there's one instance. In this case, it's been taken from the Android open source platform, source code, and you're going to have your phone LayoutInflater. These are just basic things, so you can see there's no magic here, there's no IPC. So basically, this class, even though it's part of the Zygote process, but it's going to be living inside. The instance is going to be living inside your application, and there's going to be no IPC with other services. So again, if we look at the phone LayoutInflater, it basically only adds a little value to what's in the abstract class. The way it works is that when you see text view in your layout, that actually doesn't tell you which class to inflate. So the basic class has one prefix, which is Android.view, and it tries to find the class in that prefix. The phone LayoutInflater extends it in a way that basically just adds other prefixes. It doesn't add anything else. So the question is this the best design? Because basically you do not know how it's going to work. You cannot add your own prefixes, which would make Your layout's much sleeker. You wouldn't have your need your package prefixes. This is just my question. Think about it. So this is what I've been talking about. Basically, on create view, which creates a view from a name, just goes through the prefixes and tries to create a view, and internally it's going to call constructors using reflection. And basically, these are, everybody knows, and sorry for calling out the obvious, these are your top-level inflation methods. But eventually, it's only all going to come down to one, which is the XML port parser, view group, and attached to parent. So everything is just kind of wraps that same call. So the way the LayoutInflater works internally is when you inflate a view, it tries to create the view from tag first. So this handles merge in a separate way. Then it goes through all the childs, inflates the childs through recursive inflate. The method is kind of funky, but that's actually in the platform. Then adds the views to root and returns the constructed view. And there's some sanity checks along the way, but that's really not important from the purpose of this talk. So I don't want to go through this line by line, but eventually everything comes down to recursive inflate. And through recursive inflate, the only method that is going to create your view is onCreateView. OnCreateView is being passed a name, a prefix, context, and basically that's it. So this is the sole class that is going to create your views in the LayoutInflater. So then the question is how to extend this to inflate your own layouts without having the package prefixes. And eventually, how can you apply a font to a text view without actually needing to instantiate the view class itself? Because if you think about it, if, let's say, you only want to support TextView. TextView is in the framework, but nobody prevents device manufacturers for having their own subclass of TextView, which means if, let's say, Samsung adds a new prefix and the prefix has a TextView in it, then it's going to be returned. If you are creating the view, we are going to return the platform implementation. So anything that Samsung added to support their design, their layout, whatever they need, is going to be gone. So in the end, your layout will be inconsistent with the platform or inconsistent with whatever customization the manufacturer added on. So I only mentioned one part, subclassing, really problematic because you don't know what the platform version actually is going to do. Second, how you are going to get that instance. So fortunately, there are two ways to extend the LayoutInflater. One is called a filter. I have not seen any practical use of it. Basically, you can filter out which view classes can be inflated. I would think it's practical in case if you want to provide secure UI, you don't want to allow to different views or certain type of views to be inflated. What we're looking for is the second one, which is called a factory. Since API level 1, there's a interface declared in the LayoutInflater, which is called a factory, and then later on from API level 11, there's one called a factory 2. Basically, they are the same. The signature of the factory method is a bit different, but that doesn't really make any difference in our case. So, and also there is a support library support for factories to be backward compatible, which is called the LayoutInflater factory, which will provide you both interfaces. And there's a LayoutInflater compat, which allows you to set the LayoutInflater factory in a backward compatible manner. It's important, though, that a LayoutInflater instance can only have one factory. And that kind of causes a problem because I don't know how many of you have been looking at AppCompat or how AppCompat implements supporting tinting or anything else that came in Lollipop or later versions. Basically, they install themselves as a view factory. So once that installed, you cannot install your own factory. So this is kind of a problem, which could be coped in AppCompat activity. The whole view factory registration happens in onCreate. So basically, whatever you do before that, is going to stick. So how are we going to hook into view creation, and how we're going to hijack this whole thing? The one part is we have to do it before on create. But we also don't want to lose the extra value that is being added by AppCompat to text views or any other views that are not part of the platform. So we also want to make sure that whenever we can't handle something, we defer view creation to AppCompat or the framework. So basically, what we want to do is we want to grab the LayoutInflater factory from AppCompat, wrap it, do whatever we want to do first, and defer any work that we don't want to do to the platform or AppCompat. So the reason why we want to do that is because we don't want to lose all the sweetness that has been added later on. So as I've said at the beginning of the talk, the purpose of this whole thing is to be able to apply fonts without subclassing. Now, the problem here is going to be that if you looked at how the views are being created, you don't want to duplicate the same approach because you don't know the prefixes. You don't know the platform prefixes, and the prefixes might change even in AppCompat because later, previously, there were stinted text view and other kind of views, so you don't want to lose that thing. So what we really want to do is we don't want to touch view creation. We want to defer it to platform or AppCompat, but we do want to get the view once it's constructed, and we do want to have our attributes set so we can extract whatever we want and we can apply it to the view that we want. So this is kind of tricky again. Sorry for I'm not keeping the slides in sync for what I'm talking about, but basically the point is that I don't want to do anything in code. I don't want to set fonts from code because that's going to be a designer's nightmare. Even more if they do understand Android layouts and they don't know how to change things. Second, it's a maintenance nightmare because you have to go all around your code, check different things. You can make it easy by defining constants and having certain ways of doing things, but still is going to be a maintenance nightmare. So let's go forward a bit. So the question is what we are going to do. So basically, we are going to create our own factory. We are going to install our own factory before AppCompat installs their own factory. Then we want to make sure that we call AppCompat to create the view, or we call the platform to create the view. And once that's done, we call back our own interface to do whatever decoration we want to do. So this is just a basic static layout of the implementation that I'm proposing. So we have the LayoutInflater factory, which takes all the arguments to construct the views. There's a decorating LayoutInflater factory, which derives from that. And then we have a view decorator, and we have a view factory. The decorating LayoutInflater factory basically hijacks the layout inflation, defers to the view factories. The view factories will call either AppCompat or are going to call the appropriate platform version of the view creation method. Once it's done, if it's a text view, because in our case, we only are concerned about text views and applying fonts, we are going to call the decorator, and that's it. Whatever you want to do, you're going to do in your view decorator. The implementation doesn't contain any ways of loading fonts, because if you think about it, there are loads of ways you want to apply fonts, or the source from which you want to load the fonts can be very different. You might want to load it from the network, you might want to have it as a raw resource, you might want to have it as an asset, or whatever you can think about. So basically, this is the solution. This is the approach. This is very lightweight. The benefit of this, as opposed to subclassing, is that you will have less useless classes. You can reduce your method count even by just a bit, because the implementation only about 10 or 15 methods. So that's a big gain. If you look at how many text-derived classes you have, I can count at least 5 or 6. If you have 3 constructors or 4 constructors for those, then you go up to 24. Sorry. And if you go forward and let's say AppCompat or someone else adds another text suite to your to the support library, or the platform introduces a new text suite derived class, you don't have to explicitly add support for those. You only are interested if it's a text suite. So that was basically the presentation. I would like to give a short demo if someone interested. Is someone interested? Cool. Actually, if you guys want to write it down, but I'm guessing the slides are going to be up on the meetup site. You can find the, let's say, library under this repo. It's completely open source. It's not compiled as a separate library because I didn't think the size of it would justify its own library. But please feel free to get it, download it, test it, and if you find any bugs or issues or things that I didn't think about, then please drop me a line or just drop a comment. Oh, the second link is just for those of the people who would want to explore Android but don't want to waste gigabytes of storage downloading each version of Android. I don't know if you guys know Android Xref. It's basically a site that indexes almost all versions of Android except for Honeycomb, but who uses Honeycomb? It's based on OpenGrok, so it's indexed, cross-indexed, it's easy to search, so I highly recommend using it if you want to explore how Android is built up and just, see what's up. Okay, so demo. It's not going to be too flashy, as it's only fonts, it's no animations or anything more interesting. So the demo application, which is part of the repo, just shows how the approach works with AppCompat, or if you use framework activities and you're not using anything from AppCompat. So basically, this is the first view. This uses a simple activity. It's not using AppCompat. The fonts might not be that distinctive, but they are all custom applied fonts. One of these text views, I think the last one, is the framework version, explicitly defined. The rest is just using text view with 3 different types of fonts. This is kind of just demonstrating that the approach works even if you explicitly define a class of a text view that you want to use, or just specifying text view and letting the framework or AppCompat inflate the appropriate view in replacement. And the second one is basically the AppCompat one, which does the same thing, just demoing that it works both with the framework provided activity and with AppCompat activity, adding their own stuff on top of that. And just so that I can show that it's really easy to use, let's go to demo. The only thing you need to do is just install the view decorator. Oh, yeah, sorry. Yeah, thank you. Where is that? Does anybody know? Presentation mode, cool. It's just a few lines of code. This basically just installs the view decorator. The view decorator installation is just using a view decorator installer into which you provide a decorator. And decorator is very simple. It's actually not specific to text view. So basically, this is just for being called back whenever a view is inflated, passing in the attributes, the context, and the parent of the activity. And the demo application just demos how fonts can be applied to, let's say, text use. But if you have something else that you want to do, which doesn't justify subclassing any of the framework classes because you can extract your logic into your utility classes or whatever, this approach will work in any of those cases. And also in general, having your own factories saves you a lot of trouble. Let's say you want to, I had this question before the talk. Someone wanted to replace image views with what exactly?
Facebook's image library.
Yeah, okay. So one thing you can do is you can explicitly mention that class in your layout, but then your layout is going to look really funky because you have these huge thingies in there with prefixes and classes and whatnot, even though you don't really want to have that there. You want to have them clean, you want to have them simple and easy to understand. You don't need this whole thing about hijacking layout inflation and then calling back into the platform or app.compat and then passing into attributes. What you basically want to do is you want to install your factory so that when the name image view comes in, you can inflate whatever view you want, you return it, and everything is just going to work. The only thing that you need to keep in mind is that whenever someone requests you to inflate an image view, do not return anything else. It has to be an image view or it has to be a subclass of image view. Because if you return something else, which is allowed because the view inflation method just returns a view, it will crash your application. But that's going to be really apparent and easy to understand and see. So I think that's it. Is there any time for questions or?